class we are going to cover two parts. The first part was the introduction part. The second part was the basics that you have already read in network theory, but which is a very important component in power system analysis. It is even must read in the PPT also, like power unit system and all those. Complex power. What is complex power? Anyone? You can answer. What is complex power? Yes. So actual power that is being consumed here is actually active power. But as we know, reactive power is required for conversion of mechanical to electrical and vice versa. So reactive power is needed for operation of every system. So power system must transfer real as well as reactive power. So real power and reactive power combined is known as complex power. So it is real power plus J into reactive power, P plus J. So that is also known as power triangle. Okay, you have one real power, the other one is reactive power, which are completely quadrature to each other. 90 degree phase difference. They have no relation. Okay, but we need both of them. We need reactive power so that real power can be generated, transferred, all those things. Okay. So that is known as complex power. So what is real and what is reactive power? So we consider the power, voltage and current in the transmission line to be sinusoidal, because our generators are designed in such a way that the power generation is sinusoidal. Okay. So we consider, say, as if you could have easily same way, this could have been cos omega, no problem. It's sinusoidal means sin cos. Voltage is 3 max sin omega t, current is some phase difference phi with the voltage, depending on the impedance of the circuit. Okay, depending on the impedance cycle, this phi is also known as the impedance cycle. Okay. So what is the instantaneous power? The instantaneous power is given by VI. Small symbols means it is instantaneous. Capital means it's RMS value. So when you multiply these two and simplify, we get two parts. One is the VI cos phi part, the other one is the second part. Okay, right? So this V means V max by root 2, and this is I max by root 2. Okay, so that means what are these two? RMS value. So V and I is RMS value. So VI cos phi is known as the active power. So this is what we are really interested in. Okay, everybody, 99.9% of the people are interested in active power. Only the electrical engineers who are responsible for operating the power system are interested in the reactive power, because without reactive power the system will collapse. There will be no voltage. Okay, voltage collapse will be there without reactive power. Okay. So why voltage collapse without reactive power? You must have done the experiment. OCC characteristics of generator, field current versus voltage. So only when the field current will be there, then only there will be voltage generation, because field current creates flux and voltage is directly proportional to the flux. Okay. The transmitted power evidently pulsates around an average power VI cos phi and double the radial frequency. So this is the pulsating power. Okay, this is the average one. This is the pulsating one. Okay, the above equation can be split into two parts. Part 1, part 2. This part is taken from Elgar book. Okay, very nicely it has explained. Okay, the first component pulsates around some average value, but never goes negative. Real power is never negative. Okay, whereas the second part, okay, has zero average value. So reactive power throughout the power system is always constant. It is never consumed. Okay, that's a very fine point. Reactive power is never consumed. So what we require where is something must send the reactive power to the place where it is needed. Right? That is what it is. So that's why we need the energy. Okay. Next. Okay. So if you write this down, this you know, but summarize it. P. This symbol means definition in the book. Okay. P VI cos phi is known as the real power, whereas P VI sin phi is known as the reactive power. Both all of you should write reactive power and real power. Okay. All of you should write these two things. The real power is defined as the average value of P and therefore physically means the useful power. Okay. The reactive power Q by definition is equal to the peak value of that power component that travels back and forth on the line, resulting in zero average, therefore no useful work. Okay, the term is misnomer. No useful work is required. Why it is not useful? It is useful, but not from the perspective of the loads. Okay, from the perspective of the operation of the power system is required. Okay, but it is never consumed. It's always there. Okay, so P, Q both have watts, but we say volt amperes. Reactive power is generally taken as volt amperes. So finally, what is apparent power? So apparent power is defined as P square plus Q square. This also is correct. So you have written real power, you have written reactive power. So now you write apparent power. Apparent power is equal to VI root over Q square plus Q square. So if you make a very structured note for this topic, that will be helpful for you during gate rotation. Okay, so it's your choice. Now this part all of you must be knowing. This is again taken from the electric book. Okay. So for a pure resistance, current and voltage are in phase. Impedance angle 0 or power factor angle 0 is also known as power factor angle. Power factor angle 0. Real power is positive, there is no reactive power. For inductors, reactive power is consumed, but inductor as such, a pure inductance never consumes any real power. It never should. Okay. Similarly, for capacitors, it generates reactive power. That's why when there is a voltage drop in a particular part of the power system, we use capacitor bands to inject reactive power so that the voltage is improved. Because capacitors generate reactive power. You must have studied about synchronous condensers in your electrical machines. Synchronous condensers or synchronous capacitors. Those are synchronous motors which can provide reactive power. Okay, whenever required based on their field current. Okay. So when RL circuit is there, the current lags the voltage. Okay, because inductors consume real power. Reactive. Inductors require reactive power. They consume reactive. Okay, similarly, RC circuit, the current leads the voltage. Why inductor? What is the formula for inductive reactance? J omega L. Okay, so what is the current? V by XL. Okay, so that will be J omega L as a cycle. Right? Because J omega will go below. Capacitor it will be multiplied. Capacitor is XC is equal to 1 by J omega C. So when you do V by XC, it becomes V into J omega C. So the current leads. Finally, we come to the topic of complex power. So what is complex power? Now, this phasor, you know that the AC quantities can be represented as phasors. Phasors means which have a particular angle with respect to some reference. Okay. So here the phasor has an angle alpha. Okay, and a frequency omega. Euler's formula states that is the derivation. Okay, Euler's formula says cos omega t plus alpha j sin omega t plus alpha. So we can write this voltage, since sin omega t is there, this is the imaginary part of this, this is the imaginary part of this. So we can write, so voltage is equal to imaginary part of V max into e to the power j omega t plus alpha. That is cos omega t plus alpha plus j sin omega t plus alpha. So imaginary part of this will be simply sin omega t plus alpha. So we define, you write this down, this part you write. We define the voltage phasor V as the complex number V max by root 2 e to the power j alpha. Okay, or simply as this angle alpha. Okay, and therefore the voltage time function can be written as this. Okay, right the definition.
So this is assuming the current phasor as the reference. So alpha plus or minus from the.
Yes. You cannot say current phasor. We have some reference. V0. Generally, current is not taken as the base. It is voltage which is taken as the base. Okay. So this voltage means it is with respect to the current. Okay. So this is the slide of significance. So in you write this point number 5. In power system studies, the complex power is defined as VI conjugate. Okay. Why the complex power is defined as VI conjugate? Why this conjugate sign is there? Why this conjugate sign is there? Reference changes. Why this conjugate sign is there? We just discussed for a inductor, the power is P plus jQ. For a capacitor, not inductor, inductive circuit. Okay, resistor, inductor circuit. For a capacitive circuit, it is P minus jQ. Why? Because the inductor consumes reactive power. So that's the positive reactive power. The capacitor generates reactive power, so it is minus. But when you say VI for a inductor, it will be VI some angle minus phi. Why it is minus phi? Because the current is lagging the voltage in case of a inductive circuits. Okay, so if you directly find this, so you will get VI cos phi minus JVI sin phi. But in our case, it should have been positive, right? Because inductor consumes reactive power. So we use the conjugate sign. So when we do this, we make VI conjugate, so that this becomes plus, and for an inductor it becomes VI sin phi, VI cos phi plus JVI sin phi. So JVI sin phi is the consumed positive. Positive means it is consumed, just a convention. Okay, the whole power system is built on this conjugate. So if you forget to take the conjugate, eventually somewhere you get a minus q, you will think that it's a capacitor, but actually it was inductor. Okay. So then, based on this complex power equation, we can do various algebraic modifications. Okay. These are summation results. You can go through it. These are not very complicated. Per unit system. The final thing is per unit system. You have read this in EPTD. We just revise it. Per unit means we take a base value, so that we can suppose the power system is operating at 1 per unit voltage. That means it means it is operating at its rated voltage. Okay. Or we can say in one part of the power system the power flow is 1 per unit, but in certain part of the power system the power flow was 10 per unit. That is 10 times the rated value. That is the formula. So it is easier to compare. So how we do that? So for that, to write this part only, we select a base value of voltage. Generally we select base value of KVA base or MVA base. We select an MVA base. We select MVA base. We select voltage base. We select MVA base. We select voltage base. Okay. Then we divide FV by dV to get a current base. So per unit value voltage is V by dV, current is I by IV, dV by I. Okay, or dV square by dt. Now one formula which is generally asked in the GATE exam is short question: conversion of the impedance when base value changes. Okay, for impedance you need to find out the per unit value by Z by ZB. But if you change the base MVA, ZB will change. So what will be the new per unit value of the system? Like in different sides of a transformer. In one side you have a different base voltage, whereas in the other side, suppose generator side is 11 kV base voltage. On the transmission side it is 132 kV base voltage. So the per unit value will change. So how that changes? So that you can use this formula. So write down this formula. It's very common in the GATE exam. So write down this formula. Done? Next. So your homework is, so I have shared this problem set. This problem set I have shared in the Google Classroom. So here various modules I have put problems. So this problem, some problems are compulsory, some are optional for those who want to, and review questions, for example, theoretical questions. Okay. So your job is to complete question number 1 and 2. Okay. So by next class, before next class, you should complete 1 and 2. Solution is there in the PDF.